So to repeat myself, we are working with similar triangles, and just like with similar figures, triangle is a figure. Number one, all corresponding angles are congruent. And number two, all corresponding sides are in proportion. That means that each time when you set up a ratio of corresponding sides, you get the same fraction after reduced. That fraction that is the ratio of your corresponding sides is called the scale factor. So if we are working with two similar triangles, what we know is if this is triangle ABC, we could call this triangle DEF, or we could call it A prime, B prime, C prime, but whatever we call it, and that would be A prime, B prime, C prime. When we state that these two triangles are similar, triangle ABC is similar to, that little squiggle means similar to, we must state the vertices of the second triangle in the same corresponding order so that congruent angles correspond. So I would have A prime, B prime, C prime. This tells you that angle A corresponds to angle A prime, B corresponds to B prime, and C corresponds to C prime. You also can set up your proportions. You know then that all the corresponding sides are in proportion. So AB will be to A prime, B prime. The prime is a little symbol, kind of looks like an apostrophe, but it actually is more or less that shape.
Less. Okay.
Now you can see that symbol in the book. If you look at page 255, you see A prime, C prime, B prime. Okay. And BC would correspond to B prime, C prime. So I set up my ratios. And finally, AC will correspond to A prime, C prime. And what we know is each of these fractions, or each of these ratios, will reduce to the same number. That number is the scale factor. This is part 2 of the definition of similar triangles. All corresponding sides are in proportion. Part 1 would tell you that whatever measure angle A has, A prime has that same measure. B and B prime then, and C prime. All the corresponding angles have to be congruent. That's what it means when you state that two triangles are similar. Now we're going to use one postulate with similar triangles, and then next section we'll add 2 more theorems as ways to show that triangles are similar. Our postulate 15, is the angle-angle similarity postulate. Angle-angle similarity, my abbreviation. That little squiggle is similar. Okay. And what it says is if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. We're going to do some proofs that deal with showing that things are similar. And let's do one example of a proof. So I am turning into page 258 and number 21. I have a figure that looks like this. And in this figure, I have XFS and ER. I am given that EF is parallel to RS. So I'm given that these two sides are parallel. I want to prove two things. I want to prove that the triangles are similar, and then the second thing I want to prove is the result of definition similar triangles. Because if triangles are similar, then their corresponding sides are proportional. Are you awake for it?
Mark's not free.
He wasn't, but he is now. Okay, so we're going to prove that triangle FXE is similar to triangle. If I go FXE, then I'm going to have to go SXR. The second thing I want to prove is that the ratio of corresponding sides, FX to SX, is equal to EF to RS. Now, when I'm looking at the statement of these similar triangles, I see that FX and SX are in corresponding position. They are corresponding sides. And I see that EF and RS are also in corresponding position because we have EF here as first and last. And then same thing with RS, first and last. They're in corresponding position. So this second part of the proof will come as a direct result of the triangles being similar. It's a definition of similar triangles. The corresponding sides are proportional. So the first thing we're going to be looking at is, why are these triangles similar? Well, the lines are parallel. What do we know about parallel lines? Yes. These angles are going to be the same because they are called what type of angles? What corresponding, the vocabulary words, corresponding angles. Also, we have another transversal and another pair of corresponding angles. So we're comparing triangle XFE, which is this smaller triangle, to triangle XSR. And do we have two angles in each triangle that are congruent? Do we have two angles of the red triangle congruent to two angles of the green triangle? So then we can use postulate 15, the one we were just looking at, to say that these two triangles must be similar by angle-angle similarity postulate. So let's go ahead and write a little proof here. We'll do a paragraph proof. Since corresponding angles of parallel lines are congruent is how I'll start.
Going to be the non-direct.
Usually, an indirect proof will not work.
I like those.
They will only work when you have a fact that you can contradict easily.
I like those.
But they don't always work nice. Okay, so since corresponding angles of parallel lines are congruent, by angle similarity postulate, well, let me just go ahead and say angle XFE is congruent to angle S. And angle XEF is congruent to angle R. This means triangle FXE is similar to triangle SXR by angle similarity postulate. I changed the order there, but it's the same triangles. Now I can finish it off with our last statement. By the way, do you see how I changed the order, but it's the same triangles? I just wasn't looking at it. But I did prove that first piece there. Okay. Now our last statement. So fx will be to sx as ef is to sr. By definition of similar triangles, the corresponding sides must be in proportion. I'm trying to write a Y there. And that finishes our proof. Now, here's one thing they are going to ask you to prove. And if I can get it to stay where I want it to be. They're going to ask you to prove something like this. They're going to say fx times rs equals ef times sx. What is this right here? What is this? It's the means extremes property, isn't it? You see how these two multiplied are your extremes, right? And these two multiplied are your means. So if they ask you to prove something where you have a product here equal to another product, go through the process I just went through first. The triangles are similar, so the sides are in proportion, by definition similar triangles, which means this must be true by the means extremes property. Does that make sense to people? See?
Yes.
Okay. I think I can